So we have 5 problems here. You're going to try them, and then you're going to watch me try them, and you're going to check your work against mine. Okay? And you're going to try to find your mistakes and learn as you go. I don't expect you to get all 5 right. I expect you just to improve and get better at this as we go. Good luck. So we have a system of equations because we have more than one equation. 2 or more equations is a system. The solution to the system of equations is a coordinate pair, right? A solution would be a coordinate pair in x comma y, all right? And the number for x and the number for y would be plugged in to make this equation true, and it would make this equation true. There's lots of points that make this equation true, but not this equation true. But there's only one point that makes both of them true. Okay? So we are on a mission to try to find out what that point is. We called it the dub sub method or the double substitution method. Okay? Substitution being that when you know that 2 things are equal, if you see one of those things later, you can replace it with the other thing. Like a substitute teacher, someone, if I'm out sick, they can replace me. Okay? Not that there's any replacement for Mr. Woodworth, but they can try. All right. We are, oh, and I talked about the Temple of Doom, Indiana Jones. I don't know if you saw that yet, but where he replaces a sandbag in the place of the golden idol. And he tries to make it the exact same, but where they weren't the same there, and he tripped the booby traps, which eventually almost killed him, but he escaped. Oh, sorry, spoiler. In case you haven't seen it. Anyway, let's get on to the problem. So our first step 1 in your notes was to choose one of the equations. In this case, it does not matter. Okay, we can choose either of them because they both have the y isolated, so you just choose either one. So I'm going to choose to start with y equals x plus 4. Now comes our first step of substitution. We chose that equation. Now we're going to use the other equation to substitute in a value for y. Since y equals negative x, or the opposite of x, we can take out the y in this equation and replace it with, hopefully you said, negative x, or the opposite of x, right? Because since y equals negative x, we can replace the y with negative x. All right, so we're going to take out the y, we're going to put in that negative x. Okay, and now we have an equation with only one variable. That's the whole point of substitution. All right, substituting in allows us to limit it down, get it down to one variable, and we know how to solve one variable equations. All right, there is a variable, that same variable x is on both sides. We don't like that, so what we're going to do is we're going to realize that we want to get rid of this term over here. And when we get rid of terms, we either add or subtract. Okay, I'm going to just throw a 1 in there and a 1 in here to help me out. Okay, so I'm going to solve this for x now. I have to get the variable off of this one side, so I'm going to subtract 1x. I'm going to subtract 1x. That cancels. I'm left with 4 on this side, and that's going to equal, if I combine negative 1x and negative 1x, I get negative 2x. Finish solving, divide by negative 2, divide by negative 2, and boom. Now I have half of my answer. I know that, remember, our solution is going to be a coordinate, x comma y. Well, now I know what x is. All right, x is negative 2. Okay, now comes the dub sub part. I already used substitution to get half the problem. Now I'm going to substitute this in to get the other half of the problem. In this step, I am simply going to take either one of these equations, okay, and I'm going to substitute in what I know is part of my answer, okay, and then that'll help me figure out what the rest of the answer is. So I'll just start with that same equation that I started with in the very beginning. And now I know that x equals negative 2, so wherever I see an x, I can put a negative 2. So y equals negative 2 plus 4, So y equals negative 2 plus 4 is positive 2. Now I have both parts of my answer. Okay, negative 2 and positive 2. And I put that into coordinate form. So that's going to be my x coordinate always goes first, my y coordinate always goes second. And that is my answer. Okay, if I were to substitute that answer in, negative 2 comma 2, into this equation and this equation, it would satisfy both of those equations. Okay, so that is the solution to number 1. Okay, it's time to try number 2. Let's go. All right, step number 1. Step number 1, choose one of these equations. So I'm going to choose the first one, y equals x minus 5. All right, that's step number 1. Step number 2 is to use the second equation, the unused equation so far, to substitute in to the first equation. So I know that y equals 2x, so anywhere I see a y, I can put a 2x. So I see a y here, I'm going to replace that with 2x, x minus 5. That's step 2. Okay, is using the second equation to substitute into the first equation. You're kind of combining the equations so that you only have one variable, and then we can solve with only one variable. Okay, so now step 3. All right, step 3 is to solve this equation for the variable that remains. I'm going to put a 1 here to get started. I have variables on both sides, so I need to get rid of one of those terms. I'm going to go to this side, the one with more stuff, and I'm going to subtract the 1x, subtract the 1x, cancels. That gives me 1x equals, make sure I bring down that minus. Okay, so we just get x equals negative 5. All right, that's step 3. I'm halfway done because I have my x coordinate of my solution, but I don't have my y coordinate. So what do? I'd go back up and I choose one of these equations to do my dub sub, the second substitution. I've been consistently just choosing that first equation that I started with, but you might find it's easier. You might say, oh, well, look, y equals 2 times x. That's easy. If I plug in negative 5, it's just 2 times negative 5. That's negative 10. I already know the answer. So you might be able to do it that way. I'm just being consistent. Hopefully it's easier for you to follow if I always just choose the one equation to substitute into. Okay, what am I substituting in this time? Well, I know that x equals negative 5, so I'm going to replace the x with negative 5. So y, when x is negative 5, y would be, let's see, negative 5 combined with a minus 5 is going to be y equals negative 10. Okay, and there's my other half of the solution, which is that was step 4, and then step 5 is to write it as a coordinate pair. So we got x is negative 5, y is negative 10, and that is my solution to this system. Okay, next one. We've got number 3. Okay, give it a shot. Hopefully you're feeling more confident with this. All right. So we're going to start with an equation here. Step 1 is to choose one of the equations. I chose that first one. Step 1 complete. Step 2 is to now look at the second equation and substitute in for an isolated variable. So y equals 1/2 x. So wherever I see a y, I can put a 1/2 x. So I'm going to replace that. 1/2 x equals x plus 12. That's step 2. Now step 3 is to solve for that remaining variable. So I'm going to put a 1 here. Looks like I have variables on both sides, so I got to get rid of one of these terms by subtracting 1x and subtracting 1x. Left with 12 equals, what is 1/2 minus 1? It gives me negative 1/2 x. All right, now we might be to a spot where you might be a little confused or forget how to do this. To get rid of a coefficient that is a fraction, we multiply by the reciprocal. Okay, and it looks like we have, let's see, x equals, when I simplify that, it gets me negative 24. All right, we know half of our answer, x equals negative 24. So now we have to do our dub sub. Second substitution, we go up here and we choose one of these original equations, and we're going to substitute in the answer we just got, the partial answer we just got. Okay, so I've been just using that first equation, so that's x plus 12. All right, and we have to substitute in negative 24 for x. So if y, the y coordinate of this problem is going to equal 24 plus 12, and negative 24 plus 12 is negative 12. So there's our other half of the problem, and we're going to step 5 is to write this in coordinate pair form. So that's going to be negative 24 comma negative 12. And that is our answer. And remember, what is that? That's the one point, the one coordinate pair that will satisfy both of these equations, both of those equations, if we substitute them in. All right, 2 more problems. Okay, go ahead and try this one. All right, let's give it a go. So we choose our equation. Now this one is, you might want to star this one. This one only has one of the equations solved for y, or with y isolated. So this is in slope-intercept form, that's nice. This one's not. So in this case, we can't actually start with this equation. Okay, we actually have to start with, when we do step 1 and choose an equation, we have to choose 4x minus y equals 6. Oops, negative 6. That's one of those things where you just are rushing and you don't put the negative and then your whole thing's wrong. Hopefully it doesn't happen to you. Okay, now, the reason I chose that one is because this is the only one that will allow me to substitute. Okay, do my first substitution, because it tells me that what y equals. Okay, y equals 2x plus 2, so in this equation, I can replace this y with 2x plus 2. If I were to do it the other way around and try to start with this one, this doesn't tell me what either of the variables equals, right? They're all mixed together over here. They're not isolated. Okay, so I couldn't do any substitution there. But if I choose this equation, this guy is already isolated, the y, so I can replace the y in this equation with the 2x plus 2. Okay, so I got to spread this out nice and neat. Now this is going to be tricky. Okay, whenever I substitute in one of these longer expressions, I need to put it in parentheses, especially if there's a minus sign before it. All right. Okay. Now I am going to simplify this over here. So I get 4x. Okay, it's subtracting a 2x and subtracting the plus 2. So subtracting a positive 2. All right, equals negative 6. Now this is one of the trickiest ones that we've done, so make sure you're fixing your work and learning from it, okay? Now we have to simplify. So we have a 4x and a minus 2, so that's going to be 2x minus 2 equals negative 6. Still solving. Add 2, 2x equals negative 4. Fix your work if you made little mistakes. Divide by 2, x equals negative 2. All right, that's half of our answer. Now we have to substitute in. So you can choose either of these equations. I think this one's going to be simpler, more simple to do. So y equals 2x plus 2. Y equals 2x plus 2. And we know that x is negative 2. So we're going to replace the x with negative 2. So y equals 2 times negative 2 plus 2. Y equals negative 4 plus 2. y equals, looks like -2 is going to be the answer. So we're going to, step 5 is to put that in coordinate pair form, and -2 comma -2. All right, what is that? Oops, what is that thing there? -2 comma -2? That is our solution to the system. Right, it's where the points cross on a graph, and it's the point that satisfies both equations. So satisfies this equation because if I plugged in -2, right? -2 times 2 is -4. -4 plus 2 is -2. So it would make this -2 equal to this whole side -2. If I plug it in here, let's see if it works there. Right? -2 comma -2. 4 times -2 is -8. Minus -2. So that really means plus 2. So that's -8 plus 2 makes this true. -8 plus 2 is -6. So this side would be equal to -6, this side. Okay, so this point satisfies both equations, makes them true. Last problem. Okay, very similar to number 4. All right, you're going to give it a shot. All right, let's go. So similar to the last problem, you have to choose one of these, and you're going to choose the one that doesn't have the variable isolated. So we're going to choose 4x plus y equals 26. All right. Next step is to substitute. That's step 1. Substitute. So 4x plus, what does y equal in that first equation? X minus 4. Okay, next, step 2. So that's step 2, sorry. Step 3 is to then solve for the remaining variable. So if we distribute this plus sign, you know, we can, it's just going to be 4x plus x minus 4. It doesn't change signs if we distribute addition, right? It just changes if that were a minus sign. Okay, let's put a 1 there so we can combine these like terms and get 5x minus 4 equals 26. What do we do next? Gotta isolate that variable, so we're going to add 4 and add 4. 5x equals 30. Got to do the inverse operation division here. X equals 6. All right, that's half of our answer. Now we have to do that's half of our answer, so now we have to do the substitution into one of the original equations. I'll go with that. Y equals x minus 4. That'll be simple. Okay, x equals 6, so y equals 6 minus 4, so y equals 2. We got our other half. And now we just have to do step 5, which is to write them in a coordinate pair, as a coordinate pair. So 6, comma 2. All right, that's where the two lines cross. And that is also the point that satisfies both of these equations. I hope you're feeling better about it. I know it won't be perfect because there's so many places to go wrong, but I hope you at least have the concept nailed down now. Thanks for watching.